So now we're going to take a closer look at sampling distributions. So I'm first going to show you how in Minitab we can actually get graphs and we can actually get samples from different distributions. So first I'm going to take a random sample of 1,000 data points or data values from a normal distribution, and we'll use the one that we've been using with the mean of 18 and a standard deviation of 3. So I go to calculate, calc in Minitab, and I want some random data. So I'm going to let Minitab randomly select from a normal distribution 1,000 random variables, 1,000 of them, and I'm going to store it in column 1, and it's going to have a mean of 18 and a standard deviation of 3. And we're going to take a look at how this graph looks of this data that has a mean of 18, a standard deviation of 3, and is normally distributed. So I'm going to look at its histogram with a normal overlay. That's with fit means a normal overlay, to see if it looks like it could fit underneath that normal model. And so I get this graph, and it looks very nice. For data, not so bad. I'm going to change the binning, because this is a continuous random variable, to cut points, and I'm going to have 20 intervals. Usually we like to have between 5 and 20, so I'm going to go with 20. So we see that it fits pretty nicely under the normal curve. Now what I'm going to do is I'm going to look at the sampling distribution of the sample mean for samples of size 10 for this normal that came from a normal distribution with a mean of 18 and a standard deviation of 3. So I'm going to change the title to represent what this histogram is. So now I'm going to create the sampling distribution of the sample mean for samples of size 10. And the way that I'm going to do this is I'm going to generate random data from this normal distribution in 10 of these columns, so that each row will have 10 random variables that come from the normal distribution with a mean of 18 and a standard deviation of 3. So this is how I would do that. I'd look just like what I did before for the normal distribution, but instead of just putting it in C1, I'm going to put it all the way C1 through C10. So each of these columns have 1,000 pieces of data down them, and each row obviously has 10. So now I'm going to create the sampling distribution of the sample mean for samples of size 10 from the parent distribution that had a mean of 18 and a standard deviation of 3. And the way you do that, once again, you go into calculate, but this time I want to do row statistics, and I want to get the mean of each of these rows. So my input variable is going to be from C1 all the way to C10, and I'm going to store those results. Well, I first have to select them. I'm going to store those results in C11. So Minitab, what I just told it is, I said, hey, take all these columns, each of the individual rows, add those 10 data values up, divide by 10, and tell me what the mean is. So here is column C11 is, when I plot it, it will be the sampling distribution of the sample mean for samples of size 10. And so let's take a look at that graph. I don't want a dot plot of it. I want a histogram with that overlay. And now I want to do it of my sampling distribution. And with this, I definitely want to make sure, let me make sure I get this one back. I definitely want to make sure that I have my binning somewhat equal to the binning that we see with the just the sample. And there we have that. So we can see those guys side by side. And as you can see, that sample fits generally nicely underneath the curve. And we'll change the title. And now you see that we have a really good random sample. Looks pretty normal, relatively symmetric in here, and for our sampling distribution. And again, if I take a sampling distribution for samples of size 30 or 40, it's going to basically look the same, because we know that any sampling distribution, no matter the size, that comes from a normal distribution will be normally distributed. So what happens, as we said, if we have a distribution that isn't normally distributed? Then what? Well, we're going to take a look at that. Now, you're going to see the progression for yourself as we look at this. So just to be thorough, I'm going to go to a sample size of 30 for this normal distribution. So again, the way that I would do that is I'd get my random data, normally distributed, and generally I wouldn't erase data that I had, but I'm not going to worry about it. What I'm going to do is I'm going to say I want to generate this, put this C1 through C30, because I'm just demonstrating right here. So all these have random data from the normal distribution. So what I'm going to do is I'm going to take these 30 in this row, add them all up, divide by 30, and get the mean. Do that for the second row, third row, all the way to the 1000th row. So create that sampling distribution for samples of size 30. And we do just what we did before. We calculate, not calculate, but we do our row statistic. We want the mean, but this time it's C30. Store the results in C31. And now I have that sampling distribution, and we can graph it. Keep with the same number of intervals. And as you can see, they all look relatively normally distributed, and that's what we thought would happen, well, as we were told. So now let's look at a very left skewed or very right skewed situation. So we're going to start off just like before, but this time I'm going to get data from a distribution I know is relatively, is right skewed. And it's got a mean of 1 and a standard deviation of 1. And in here, we'll look at what it looks like with the normal overlay, just like before. Oops. And as you can see, really right skewed. Okay. So now we're going to make our sampling distribution of the sample mean for samples of size 10. So we're going to follow the same process that we did before. We're going to make 10 columns of exponential from the exponential distribution. So I'm going to store those in C1 through C10. And I'm going to do my row statistic, getting the mean. And I'm going to store that in C11. And now I'm going to take a histogram of that sampling distribution for samples of size 10. I'm going to change the binning because we like to have that at the cut points. 20 bins. I need to do that to the other graph. And as you can see, we now have a graph here that is starting to look not as right skewed. It's starting to get a couple more bars this way, and it's starting to look a little symmetric. So we're starting to see the central limit theorem in action. I'm just changing the binning on that. So there we have our graph right there. This is X bar. These are all the means for samples of size 10 that we graphed. So now it's time to do the sampling distribution of the sample mean for samples of size 30. So we do the same thing that we did before. So I'm going to override all this data and create all new data. Generally, like I said, I usually keep my data, but this is just for demonstration purposes, so it's okay. So I'm going to go to 30. Now all the cells are replaced with new exponential data, and I'm going to now take the row statistics. I'm going to take this first row, again, add them all up, divide by 30. Well, not me, but Minitab will. Divide by 30, so I'll get 30, I'll get means for samples of size 30, and I'll have 1,000 of those means, and I'm going to graph it. Now it's time to take the row statistics, to calculate the row statistics. This time it's C30. Store it in C31. Okay. So now we have the sampling distribution of the sample mean for samples of size 30, and now it's time to graph it. And look at that. It looks really nice. It is reasonable to assume that that data is normally distributed. For the most part, it's looking pretty nice. There's just a little bit over there, not too terribly much. So very nice. So you get to watch the central limit theorem in action. So that's the progression of a sampling distribution. Now a quick look at the notation for sampling distribution that I'd like to go over with you right now. Remember that this is the symbol that we use for the mean of the sampling distribution of the sample mean. Here's the standard error of the sampling distribution of the sample mean. So this is the mean of the sampling distribution. Of the sample mean. And this is the standard deviation of our sampling distribution of the sample mean we call the standard error. And if we were doing the sampling distribution of the sample proportion, we'd say the mean of the sampling distribution of the sample proportion and the standard error of the sampling distribution of the sample proportion. So these are what we would use as symbols when we're talking about sampling distributions. So that was just a really good look into sampling distributions. I will come in and we're going to be doing confidence intervals and hypothesis testing. Thanks.